Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome everyone to the mini-series Next Generation Energy Leaders by the podcast Insider's Guide to Energy. I'm Luca, and with me today is my co-host Jill. Hi.
Hi Luca, how are you doing?
I'm very well. How are you?
I'm really well as well. I'm fine as well. I'm really excited for this episode.
Yeah, we'll be talking about a very hot topic today. We'll be talking about hydrogen, more specifically about hydrogen in transport, but maybe also other things. But rather than just talking nonsense, let me introduce you to Ted McElveen from the company Verne. Hi, Ted. How are you?
Hi, thank you for having me today. Excited to talk about hydrogen transport, and what we're doing at Verne.
Cool. So let's dive right into it. Maybe give us a short introduction of yourself and what Verne does exactly.
Yeah, so at Verne, what we focus on is high-density hydrogen.
Yeah.
And so as we can talk more about, in order for vehicles to really travel their full range or carry their full payload, it's important that they can store enough hydrogen on board. Mm-hmm. And that's what we're working at Verne to achieve and to accomplish. Mm-hmm. And the way we do that is by storing hydrogen in what's called the cryo-compressed state. So that's as a gas that's very cold. Mm-hmm. So unlike the two conventional ways of storing hydrogen as either a compressed gas or a liquid, we store it in what we see as really the sweet spot between these two states, really maximizing the density while also avoiding some of the other challenges that comes with the other ways to store hydrogen. Okay. So that's what we're really focused on at Verne. I guess a bit more about me personally. I've been working on Verne for the last 2.5 years, but I've really long been passionate about climate change mitigation, and that's really our full focus at Verne. I'm a very mission-driven company here with the objective to decrease emissions in heavy-duty transport, which makes up 10% of all CO2 emissions. Mm-hmm. So that's what really got the company going, and it's what gets me really passionate and motivated to come to work every day.
Yeah, that's very cool. I just had to think about the hydrogen ladder by Michael Liebreich. I don't know if you're familiar with that. Heavy-duty vehicles being on the very top of that hydrogen ladder, so very important and hard to decarbonize, actually, yes.
Definitely aware of that ladder, and he has, I think, at the very top level, some of just the feedstocks for current chemicals that already use hydrogen. But right below that is where you do see some of those heavier applications, such as mining haul trucks.
Yeah, very interesting. So maybe we'll get into the technology a bit later. So you said you've been on with Verne for 2.5 years now. How did it all start? What did you study, and how did you meet your co-founders? So you have two co-founders. How did you guys meet? How did that all evolve? And was it
so why don't we talk back a little bit? I was previously working in energy storage. Actually, I've participated in energy storage in a couple different ways, I guess, throughout my career. I was a chemistry major in undergrad. Okay. Yeah, I got a degree focused on battery engineering, actually. So worked on developing new technologies for grid scale energy storage. After a short stint as a consultant, I worked again on battery storage for the grid, this time on a software role. Okay. But I left that job to go to business school with the real focus of working on one of the difficult to abate sectors. And so I was motivated by the work I was doing, working on the grid, and know that clean electricity is really vital to hitting net zero targets. Mm-hmm. But there's another 70% of emissions that it doesn't come from electricity. And that's what I really wanted to address. I wanted to address emissions from industry, from transport, or something like agriculture. Mm-hmm. But with that focus, that's what really led me to go to business school, to start to explore new opportunities, is when I came across hydrogen. Actually, I was at an energy conference hosted by Stanford where I got my MBA right at the beginning of the MBA program. And all the researchers at Stanford were really highlighting the importance of hydrogen and that hydrogen could play in a net zero scenario, addressing these sectors that I was passionate about, transportation and industrial heat. This was not that long ago, back in 2019, but at that time, there wasn't nearly as much commentary on hydrogen yet. We hadn't really started to climb that momentum that we're feeling now within hydrogen. So at that point, I really got excited about it. It was one of the first times I actually truly learned about the important role that hydrogen can play in helping us decarbonize our economy. But what I realized, or what I was hearing from these researchers at Stanford, is that there's really a missing link in the hydrogen value chain. There's always a lot of research and commercial activity going into hydrogen production. So a new electrolysis technology and companies, methane pyrolysis, various forms of producing hydrogen, and then a lot of activity on the usage side as well. So whether that's new fuel cell technologies or end use applications such as ways to produce steel without such an intensive CO2 emitting process. There's a lot of innovation and commercial work going on either sides of the value chain for hydrogen, but very little activity focused in the middle of the value chain. That is the storage and distribution of hydrogen. Not only was there little commercial activity, there also wasn't a lot of technology innovation. Essentially, the ways that hydrogen is stored and transported today are either as a compressed gas or as a liquid. Pretty archaic technologies for such a rapidly evolving supply chain and evolving marketplace. So I got pretty excited about that white space, technical and commercial white space, focused on the middle of the hydrogen value chain. At which point I called up my former classmate from undergrad in the chemistry days, David Jaramillo, and David had left undergrad and stayed in chemistry, unlike myself, who made the pivot over to the dark side, over to business. David stayed with chemistry through and through, got his PhD at Berkeley out here in the Bay Area, with that focus on gas storage and separations. And so he was really kind of my first phone call, and a rather serendipitous call, because it turns out he was heavily focused on hydrogen. He was part of the National Research Consortium on Hydrogen here in the US. And knew a lot about the space. So he got pretty excited about what I was working on and decided to join forces and help co-found the business. So he's currently our CTO, really taking that technical leading role. And then shortly thereafter is when our third co-founder joined the team, Bav Roy. He's currently our COO. I met Bav in business school, actually at that first energy conference that I was talking about. So met him at that conference and continued to stay in close contact with him, and really has helped round out the team really from the earliest days.
Yeah, you mentioned that you before worked more in the electricity sector, like grid sector. What were the reasons that you then thought hydrogen is the best solution to address decarbonization, especially from the transport and the heating sector, and not maybe electricity?
Yeah, I think electricity has a very important role to play. And like I was mentioning, about 30% of emissions currently come from power generation. And while that's the statistic now, we all know that's going to increase. More of end energy is going to come from electricity in the future, and it has to come from electricity in the future for us to hit a net zero target. So the old mantra of electrify everything and then clean up the emissions profile of electricity, I still do believe in. Electrify as much as we can, and then make sure that electricity is clean. That's going to be vital for us to hit net zero. But the challenge really comes with that electrify everything, the first part of it. There's certain applications that are just incredibly difficult to electrify based on their energy requirements. One example is heavy duty transportation. And it's very different from light duty transportation, which we do at Verne believe can be and should be electrified. And one of the differences I think that is important to keep in mind is we already have different fuels for heavy duty and light duty transportation today. There's diesel for heavy duty and for heavy duty road transport and gasoline for light duty road transport. They have different demands, different criteria that matter in these industries. We already see that today with the different fuels they use, and similarly in the future, they're going to have different energy requirements, which make electrifying the heavy duty sector very challenging to make economically viable. And so that's really some of the underpinnings of how I got excited about hydrogen is realizing some of the shortcomings of electricity and of a pure electricity play in terms of a battery electric, I guess I'm mentioning when it comes to transport.
Yeah, cool, fascinating. So let's talk about the technology. Maybe guide us through the main components of your. I know it's it's basically a container, but do you deliver compressors with it as well? Maybe take us through the components of your technology.
Yeah, so if we start to think about just the real objective, and that is for these heavy duty vehicles, we're talking very large trucks or mining haulage trucks, and eventually other applications such as maritime or aviation or locomotive. But in the earliest days for us at Verne, a very large truck.
Okay.
These trucks need to carry an immense amount of payload and travel long distances, operate rather continuously at very long shifts, oftentimes with multiple drivers, so they can really increase that utilization of the working asset of the truck. And so they require a lot of energy on board. They need to store a lot of fuel.
Okay.
In trucks today in the U.S., a truck can store enough diesel to travel 1,200 miles, and that's so they have right now a lot of power that they store on board.
Okay.
In their fuel storage. So that's really our goal, is to enable them to continue to use those diesel type operations, but with zero emissions. In order to give them that diesel performance, we need to get a lot of hydrogen on the vehicle. Compressed hydrogen is simply too low in density to do that.
Okay.
With the compressed hydrogen today, a truck can drive around 400 miles, so about a third as long as a diesel truck could currently travel today. Our goal and what our real objective was at Verne is to make a truck that could drive a diesel parity distance and have that performance characteristics in terms of range or in terms of payload. So, having a light storage system with a lot of power that doesn't start to eat into their revenue, doesn't start to chip away at how much weight that they can carry. Yeah. So that's what we're going for. And I know that the question is a bit more about, exactly how we get there, but just to set the context. Yeah, the way that we get that high density then is by storing hydrogen not just as a compressed gas like it's done today, but also very cold. And so what our product looks like on the truck is essentially a pressure vessel, a carbon fiber wrapped pressure vessel that is able to store the hydrogen at high pressure, but it's also insulated. So it keeps the hydrogen gas very cold. And we're talking quite cold, around liquid nitrogen temperatures, around -200 Celsius. Okay. So it is quite cold. And that insulation around the pressure vessel keeps it in that state. Okay. The benefit of storing it both as a compressed and cold gas is that we're able to get density from both of those elements and really get to a liquid level of density. Okay. And so storing it in the state compressed and cold, or cryo-compressed as it's called, we get to the same density as liquid hydrogen. Okay. And I guess that brings me to the second product that we have. The first one is that onboard tank system that stores it compressed and cold. The second is a product that would go at a refueling location to do that processing, to take the hydrogen gas input and compress it and cool it. And so when hydrogen is produced, of course, it's around ambient temperature and very low pressure. And so we need to do that process to compress the gas and cool it to get it into that high density form. So that's really our second product. So those two products, that fueling station equipment as well as the on-vehicle equipment. So at what pressure? Normal gas vessels have 700 bar. Is that correct? Yeah. So today there's two real standards: either 350 bar, which is what a lot of buses are storing hydrogen at. Forklifts are storing hydrogen at 350 bar, and a couple trucking companies want to store hydrogen at 350 bar. Or 700 bar. And so 700 bar, of course, twice the pressure. And very, very high pressure, and that's what some other large trucks are storing hydrogen at, as well as passenger vehicles.
Okay, interesting. So maybe let's talk about the supporting infrastructure needed for that, and supply chain issues, basically. So you need pipelines, right? And how does that compare if you have? So we talked about gas and we talked about liquid. What are some of the differences when you choose heavy duty hydrogen in liquid form or gas form? What are the effects on the whole infrastructure side? Or
we see this as a really important consideration when truck fleets or truck manufacturers are selecting what hydrogen technology to install on their vehicles, is to consider the actual entire supply chain to ensure that they can refuel their vehicles with hydrogen. Now, as I was talking about the importance of high density and having high density on board the vehicle, the truck manufacturers and fleets are acknowledging this. They're currently building them, as I was mentioning, with compressed gas on board. But they know that that's really kind of a stepping stone for them to prove out the rest of the powertrain, prove out the overall hydrogen fuel cell platform. But they know they won't need to get to that higher density to really hit the economics that they're going for. The way they're thinking about getting the higher density, or the conventional way, would be to go to a liquid hydrogen. Store hydrogen as a liquid. It's high density, can give you that full range, full payload that the density provides. The problem is that with liquid, you're really restricted to fueling stations that have liquid hydrogen. So you need to, if you have a truck that has a liquid tank, you have to show up to a station with that has liquid hydrogen supply. The reason is when you store liquid, it's low pressure. So it's essentially a metal cylinder that stores this low pressure liquid, insulated, of course, but you need that liquid hydrogen supply. Whereas if you have a compressed gas tank, and so I'm not even talking about what Verne does, but just the conventional way to fuel a truck today with compressed gas, you can show up to a station that has compressed gas that was delivered via a pipeline or produced on site and compressed on site. Or you can show up to a station that has a supply of liquid hydrogen, because you take that liquid hydrogen, send it through something called a cryo pump, which pressurizes the hydrogen and gasifies it. And then you send it through vaporizer tubings, which warm it up, and then you fuel your truck. And so if you have a compressed gas truck, you can fuel at either station. That's a real benefit of compressed gas. But back to the problem with compressed gas, that it doesn't have the density that's required. This is really where Verne and cryocompression comes in. You can fuel a cryocompression tank if there is a gaseous supply using our station equipment I was talking about. If there's a gaseous supply, whether from a pipeline or on-site production, on-site electrolysis, for instance, you can refuel there using our compressor and cooler, starting with that gaseous form. If you go to a station that has a liquid supply, a truckload of liquid coming in and delivering that liquid, you can also refuel using that commercially available equipment, the cryo pump, taking the starting liquid hydrogen, pumping it to high pressure and gasifying it. The only difference relative to the way it's fueled at a compressed gas station today is we would bypass that vaporizer. And so we just keep it compressed and cold rather than warming it up again before fueling. So the real benefit there is a cryocompression vehicle can be fueled at any source of hydrogen, whereas a liquid hydrogen truck could only be refueled where there is a source of liquid hydrogen. The last thing I'd say to put some numbers on this is there's very little liquid hydrogen that exists today in the world. There's enough liquid hydrogen to fuel outside of the US, so setting the US aside, about 1,000 trucks per day total across the whole globe. In the US, we have a lot of liquid hydrogen because of the space program and a few historic uses of liquid hydrogen. So we could fuel about 6,000 trucks in the US. But still, we're talking less than 0.5% of all the global trucks to be fueled with today's liquid hydrogen supply. So we're just very far off where we need to be for this to become a real dependable supply chain.
Cool, thank you.
I actually do have a question on that, especially on the technology itself. Do you have competitors and other firms doing, like, having the same idea and doing this cooled compressed gas, or like, how do you see the chances even in this being the new standard?
So as far as our competitors go, what our biggest competitor was when I started the company was liquid hydrogen. That was where we saw as the option that the truck companies were looking at as their option to get to higher density. And a couple large truck companies are still considering liquid hydrogen as a way to get to high density. We'll see if we can win them over with especially that supply chain flexibility that I was mentioning. But since we've started Verne, one direct competitor has emerged that's worth bringing up. Their name's cryo-compressed. It's a company in Germany, and that company was founded by a man, Tobias Brunner, who was involved really in some of the early research on cryocompression. And so just to kind of wind the clock back a little bit and talk about where cryocompression came from, it really actually, it's not a new concept within the last 2 or 3 years. It's really been heavily researched, in particular at a national lab here in California. Starting in the late 1990s, there was about 2 decades of research on cryocompression. That really was focused on applying cryocompression to light-duty vehicles. There was a big push both, in the US, also in Germany, for hydrogen light-duty vehicles in the early 2000s. And cryocompression was one of the technologies that was considered and really experienced a lot of R&D and a lot of federal money spent here in the US to help advance the technology. As we've seen, battery electric's proven to be quite capable in the light-duty vehicle sector, and cryocompression was somewhat forgotten about as a technology that had received so much interest. Until recently now, where the importance of hydrogen within the heavy-duty sector is becoming so apparent. And so that all that work that had been put into cryocompression out here at Lawrence Livermore National Lab is really being revived. And it's being revived by ourselves at Verne, as well as this company, this German company, cryo-compressed. And that is actually no surprise. The team that we have at Verne is actually really supported by the Lawrence Livermore team members. So our technical advisor, Salvador Seves, is really the original inventor of cryocompression. Issued the first patent on it back in the late, wrote the first paper in the late 90s, issued the first patent in the early 2000s. So he really brings a lot of his decades of experience to Verne, as well as a few of his former team members at Lawrence Livermore who are now full-time employees with us. The other involvement, this other competitor that we have, the German company, was also involved in some of this early research at Lawrence Livermore. Back then, the founder of that German company was at BMW when they were working on a project out here at Lawrence Livermore. So the two companies really are chasing the same thermodynamic state of supercritical hydrogen, this cryocompressed state, cold and compressed. Their company's focused on in Germany as their first market. We're focused in the US. And so while technically, yes, they're a competitor, we're actually glad they're out there. We think that in order to really steer such a massive industry, we're going to need a lot of voices at the table that are helping spread the word about the benefits of cryocompression. Yeah,
cool. That is very fascinating. So maybe it's interesting that you mentioned this German company, because in Germany is basically big on hydrogen over here in Europe. They are investing, or they have policies in place for this. As I'm not very familiar with the States and how things are going there, what's the picture like there? Is there any policies? Are there states that are really front running this? What's the picture?
Yeah, so there's been growing momentum for hydrogen also in the United States. There's just a bill that was passed. It was actually a much larger bill on infrastructure improvements. But within that bill, $9.5 billion were allocated for hydrogen. So that's definitely providing some needed funding to help really stimulate some of the hydrogen growth here in the US. And what that bill really focuses on is 2 components. One, $8 billion for hydrogen hubs. Those are conceived to have large production with a variety of different offtake for that hydrogen. So some trucking fleets, some industrial uses, but to really concentrate the development of hydrogen infrastructure in one area and provide a lot of federal funding, grant funding for that within this infrastructure bill. So that's been one of the largest real deployment of or allocations of capital towards hydrogen here in the U.S. is the recent infrastructure bill. But we're seeing kind of growing momentum just really across the political sphere as well. And not all of it's gotten into law yet, but there have been things such as a bipartisan bill introduced for hydrogen for trucks. I think it's called the Hydrogen for Trucks Act. So that there has been growing interest and a lot of interest also from really on both sides of the aisle. So as bills kind of are some bills here in the U.S. are stalling in Congress, there's a lot of optimism that hydrogen will be a part of a climate policy that's passed, because it does have that bipartisan support.
Yep, that's very interesting. Thank you.
And apart from like the whole increase in interest in hydrogen, what do you think, or what are your biggest findings so far over the last 2 years?
Just generally for the company, starting the company.
Yeah, generally company, but also the whole industry.
Yeah, it's been an interesting, I think, evolution over the last couple of years in where the interest lies within hydrogen, and just 2 years ago or so, people were in love with the different colors of hydrogen: green hydrogen, blue hydrogen, and now I feel like every hydrogen conference I go to, people will talk about how we want to move away from the colors and focus just on the carbon intensity of the hydrogen itself, because there's a recent acknowledgement of the really diversity of production methods that make some sort of color scheme harder to follow and less precise. Yeah. Green hydrogen electrolysis can be more carbon intensive in some instances than other production methods if the electricity is coming from coal power, for instance. Whereas methane pyrolysis could be very low carbon or even negative carbon if it's made with renewable natural gas as that methane source. So I think one of the shifts that I'm definitely seeing is this evolvement towards really just I recognize the importance of carbon intensity, but using that as the actual number rather than some of these kind of shorthand with the colors. So I think that's been one interesting transition I've seen. The other big shift is that hydrogen's really come out of the shadows of these national labs that are interested in it and academic research groups, which is where it was when I started to get involved in 2019. When I started working on the company, my parents, my grandma didn't really know what hydrogen was, but now it's on the front page of the paper. So I think just that public recognition of and understanding of hydrogen and what it can do has been another major shift. I think the last one I'd mention is just all of the increased involvement from the oil and gas sector in hydrogen. Of course, historically, a lot of these companies have some of the most experience working with hydrogen as they use hydrogen in the refining process, but they also have a lot of experience in gases, and that's would lend itself very well to hydrogen. But I've really seen an increasing buildup of interest from the oil and gas sector.
Yeah. Maybe as we're slowly coming up to time here, I wanted to ask you, what are your next, let's say, short to medium term projects that you're looking to do?
Yeah, so one of our real near-term projects that we're working on is to actually have our tanks on a vehicle and have that driving around on the roads. Yeah. So what we've built a prototype, and there's been all this research that's gone into cryo-compression before. So we know that it works. We know that we can hit these thermodynamic states, this really high density. That's all proven out. But of course, what we need to do now is to have that on a customer's vehicle and driving around. So that's what we're actively working on now. We'll be on the roads driving a vehicle later this year, and are then ramping up our systems really to do a commercial truck pilot in the near future here. So that's really the milestone that we're driving towards is to have a full tank system that can drive a truck really diesel parity range on a large truck. And so that's our near-term focus, is really that demonstration program in a commercial context for a truck fleet.
Sounds exciting.
So for the very last question, I think you've already talked a lot about in the beginning about your motivation. This is something we usually ask our guests, but there is another question, and it's about graduates and what you would tell them. So recent graduates, they're looking to make their first steps into the industry. What would you, what advice would you have for them?
Yeah, I would say, well, don't be shy and get on the phone and just start talking to people, because I think I've learned way more from conversations with recent founders of companies, with people that are a year or two in the industry, than you really can ever learn from your studies. Of course, it's important to get those fundamentals and go to university and all that. But in terms of really understanding what it's like to work at any specific job, I think you just have to branch out and get out there and get on the phone. And I think you can get a really good sense of what different industries are like and what different companies are like from meeting people. And I went from being kind of a timid networker to almost a networking addict over the last couple of years. So I just really see the value in making connections, and it's one of those things where you never know where a conversation will take you, or how it might impact you in a few months. And so, as important as it is, I think, to read the white papers and come up with your own ideas and theses and which way the industry is going to go, I think you just also have to put yourself out there and get on the phone or grab a coffee with somebody to hear their perspective and hear what their life's like.
So once again, networking is essential. So yes, I think we're coming to an end. Thank you so much, Ted, for being on the show. It has been a great pleasure hosting you.
Yeah, thank you so much for having me. I'm clearly very passionate about hydrogen, and just am very excited to be working on decarbonizing a major source of emissions. And so, yeah, I really appreciate the opportunity to talk with you all today about what we're doing at Verne.
Yeah, I was going to say, I can really see that passion in your eyes when you talk, which is really nice. It's been very insightful, and I'm obviously looking forward to hearing about your projects in the future. And for our listeners, thank you so much for joining us today. And remember to like and subscribe to our show. And we're looking forward to talking to you soon. Goodbye.